So when you connect all three switches in series connection, the third condition will be satisfying. Okay. So now here, let's take the first condition. Okay. In this problem, for the first condition is telling that any one switch is on, lamp one should be only lamp one should be on. So when I execute operating switches individually, the condition is satisfying. Let me on two switches simultaneously. Let's see what happens. When I on two switches simultaneously, that time also lamp one is getting on. But when two switches are on, lamp one should not be on. Okay. So when I make all three on, even lamp one is getting on, lamp three is also getting on. Correct. So I need to avoid this. Now what will I do? There are two methods to approach this problem. So I'll go with the output addressing method. Okay. So now what I'll do, I'll take this output address to break this one. Okay. So I'll take the output address here. Now, if I make all three switches on, this lamp will be on. When this lamp is on, I have taken this lamp condition in NC connection. That means whenever the signal, whenever it is giving a high signal, this will be the switch, the NC contact will be giving a low signal. Therefore, the lamp one will get off. Okay. Now, but what is happening whenever I make two switches on, any two switches on, that time also lamp one is getting on. Correct. Now, what I'll do, I'll take the second condition. Okay. So what a second condition is telling? It's telling any two switches. So combination of two switches I have to take. So it might be S1, S2 or S2, S3 or S1, S3. How I am going to connect it? I am going to connect it in a parallel connection because it is saying that any two switches. Okay. So if I on any two switches, lamp 2 should be on. Okay. Only one switch is on. So therefore lamp 1 is getting on. Lamp 2 and lamp 3 are in off state. Okay. So let me on the switch. So now lamp 2 is on. So any two switches are on. The lamp 2 will be on. The condition is satisfying. Lamp 3's condition is also satisfying. But lamp 1 is getting on. To avoid this, what will I do? I'll be taking this output address and I'll be latching here. Let me on all three switches. Then we'll see what happens. So when I make all three switches on, lamp 1 is getting on, but lamp 2 is not getting off. So I need to off lamp 2 as well. For that, I need to repeat again this condition here as well. Okay. Now any one switch on, lamp 1 is getting on. Any two switches are on, only lamp 2 is getting on. When all three switches are on, lamp 3 is getting on. Okay, understood? Any confusions? Can anyone please confirm? Should I explain from the beginning again?
Madam, once again repeat it, madam.
Okay. So now what was the problem statement I had given to you people? It was like you have three switches and three lamps. In that, if you on any one switch, only lamp one should be on. When any two switches are on, only lamp two should be on. And when all three switches are on, only lamp three should be on. Okay. Now, whenever I on all three switches, we'll go in the reverse order. Okay. So when I make all three switches on, only lamp 3 should be on. Correct. So how I am going to connect it, whether in parallel or series, I need to think about it. So whenever you remember the AND gate operation, right? If you consider the statement, it tells that when all the inputs are on, then only the output will be on. So when all switches are on, output lamp 3 should be on. That means you have to connect the switches in series for third condition. Now we'll go for the first condition. Now in the first condition, it is telling that any one switch on. So it is resembles to the OR gate condition, correct? If any switch, any one switch is getting on, lamp 1 should be on. But in the OR gate, if all the inputs are present, if the are in high state, then output also was getting on, correct? But here, if all the states become high, it should not get on. Only one switch is on, that time only it should get on. Okay. Now in the second condition, any two switches, it is the combination of switches. When they tell any two switches, you have three switches, right? You will get a three combinations. Either it is a combination of switch 1, switch 2, or switch 2, switch 3, or switch 1, switch 3. Three combinations you'll get of two switches. Okay. Now, whenever those two, like combination of two switches are on, any two switches are on, it might be one or two, or one or three, or two or three. That time only lamp 1 should be on. Now, what happens is that if I won't use this breaking condition, the NC connection, that time what happens is that when I make any two switches on, that time also lamp 1 will get on. When I make all three switches on, that time lamp 1 and lamp 2 both will get on. To avoid that, what will I do? So here I'm going for the reductioning method. Okay, directly I'm using output condition. Now outputs are like storing elements. Okay, so now what happens is that this output will be storing a high or low condition based on the switching operation. When I make all three switches on, it will be storing one. Okay, when this gets on, now this address has a value of, let's imagine this is an address. Okay, now this address has a value of 1. Now this address value, I am giving it to the switch. Now this NC switch is getting a value of 1. If this switch gets the value of 1, what happens? Its a function is to invert it. Whenever it gets a value of 1, it will off it. Okay, thereby breaking the signal when all the three switches are on. Similarly, when two switches are on, any combination of two switches are on, lamp 2 will be storing that condition, either high or low. Now, what this address, let's imagine this is address. Now, this address is storing a value of 1 or 0. Whenever I use this address repeatedly at the input side again, now this address is having 1 or 0. Based on the contact I am using, either NC or NO, the operation will execute. Since I am using here NC contact, whenever I give a value of 1 from this address, it will be inverting it and it will be giving a 0 signal, thereby breaking this current line. Therefore, the output will go low. Understood?
Yes, ma'am.
Any confusions? There is one more method by taking truth table or by taking repeated inputs. Okay, that looks a little bit messier. I'll show that also. Okay. Okay, the first condition is any one switch is on, correct?
Madam, is this first problem or second problem?
Yeah, this is the first problem. Today's first problem, yes. Not the schematic diagram one, the other one.
Madam, yesterday problem.
Yeah, yesterday,
doubt.
like after I gave one problem, no, any one switch.
Yes, ma'am. In that,
Ah.
uh, I have around 3 rungs. Okay, in first rung, switch 1 and I take switch 1 as a NO and switch 2 as a NC.
No,
Then
not schematic diagram one. I texted you, no? In the group, I texted telling that anyone switches on.
No, last you did not that problem, madam. Can we do in another way that problem?
Yeah, you can do it in another way. I am doing that one only. Okay. So now this is any one switch is on. Okay. Now what will I do? Only one switch should be on. Then let's say I am owning only switch 1. So other two should be in the off state. So I'll take it in NC connection. Mallikarjun, you did something like this?
Yes, ma'am.
Okay.
But I taken 3 lamps. For each rung, I taken 3 lamps, 3 out.
For this one single condition. Okay, let me check.
Lamp 1, lamp 2, lamp 3.
Okay. Let me check. So now here, if I on any one switch, the output will be getting on because if other two switches are in high or low state, it will not get affected. This one will not get affected. Okay. So 1 second. So now any two switches are on. If the third switch gets on, lamp should not get affected. Therefore, I'll be using it into NC switch. Okay, this is one more approach. Okay, see here, what I'm doing, I am repeating the input address at the input side, either in series or parallel. Okay, so here Any one switch is on, output will be on. Here again the combination. Any two switches on, lamp 2 will be on. If all the three switches are on, lamp 3 will be on. Okay, understood?
Okay, madam.
Okay. So the operation will be same. So if any one switch is on, lamp 1 will be on. Any two switches are on, only lamp 2 will be on. If all three switches are on, lamp 3 will be on. Okay. Now this looks a bit like complex one. So many switches we are repeating, so many addresses we are repeating. When we have the chance of using output addresses at input side, so we can reduce the number of contacts we are using. Okay, thereby we can reduce the program size. Okay, Mallikarjun, how did you do? This is how you did, right?
No, ma'am, I wrongly understand the question.
Okay, fine.
So
You go.
when only one switch on, lamp
Hmm.
1 on. When two
Hmm.
switches on, lamp 2 on. When
Huh.
three switches on, lamp 3 on, like that. You said any one switches like you used.
Okay.
Madam, actually here three rungs are there, madam. But I thought only one rungs, so three switches. I thought, madam.
Okay, no. See, three different conditions are there, no? So
Madam.
three rungs will come. Okay, any confusions? Is it okay? Is it fine? Everyone understood?
Yes, ma'am.
Okay. So now who and all did the schematic problem, the schematic to ladder conversion, ladder logic? Who and all did that problem? Did anyone tried it?
No, madam.
Which one, ma'am?
Schematic conversion from schematic to ladder diagram. These
Okay,
problems.
this one you done. This one you done. This
Yesterday,
one, no?
yesterday I
Yeah,
explained this one. Right?
yeah.
Can you see this?
I send it. You pick, no?
1 second, I'll share the screen.
Yeah.
So this one, 1 second. This one.
Yeah, ma'am. I send it. You pick, no? You said that correct.
Madam, try, madam.
Yeah. Okay. So the first one was correct. Okay, what about the second one? I have to check it again. Give me a minute. So can anyone explain how the second condition works? Okay, Srinivas.
Madam,
You have one, I'll tell you first only. See, whenever we take switches, like push buttons and no, level switches, there are varieties of switches. In that also, there is NO type switch and NC type switch. Okay. Whenever we'll be explaining ladder diagram programming, we'll be considering only NO switches. That means normal on off switches. Like when I make it on, it will be on. Okay. Not like two-way switches. Like when I see switches in the off state, but still the lamp will be on. That is a two-way switch condition, right? It's like NC switch. So similarly, whenever I take a push button, there are two combinations. One will be NO switch and one will be NC switch. Let's say in your industry, you are given with two, one NO and one NC switches. How are you going to write a ladder diagram for that? Okay, so for that reason, I have selected this one. So how the ladder diagram looks, can anyone tell?
Madam, NONC, madam.
NONC.
I'm not understanding. Yesterday I missed
Um,
the class.
No, I said yesterday I didn't explain. I just gave a brief introduction for this. See, what we are what I have given here is that I am considering one NO physical switch and one NC physical switch push button. Okay, whenever we take
Okay.
switches, there are the inbuilt connection of the switches, like one either will be NO or NC. So now let's say I have given with the NC switch. Okay, not a NO switch. If I given with the NO switch, whatever programs we write, okay, that is for NO switches only. Now, if I given with the NC switch, how I'm going to write the program? Now, yesterday, okay, do one thing. Try to do a ladder diagram for this one. Okay. So now I'm using two NO switch. This is an off state. This is an on state. Okay. You're getting it?
Yes.
Okay, now first try to solve this one. Because we are using two NO switches, how does the ladder diagram looks for this one? Try to solve this one. Next, we'll go for the other problem. Satya, I'm really sorry. You did both problems wrong. You have repeated input address. You're using only one switch for whole
Yeah,
problem.
yes, ma'am. Yes, ma'am. You corrected, but NC
I
or
just saw the
NO.
program, but I didn't understand the address. I didn't see the addresses. That's wrong.
Yeah,
Okay, now try to solve this one.
okay. I
Sushant,
corrected, but
okay, try it out. Sushant, are you getting it?
I'm showing simulation problem.
I didn't get you. Sushant, are you understanding?
Yeah, ma'am.
Okay, do it.
Madam, question I am not understanding.
Now write a ladder diagram for the schematic. That's all. You have two push button. Okay?
One is NO and one is NC, right?
No, not two NO push buttons you have. Okay? Okay. Wait a minute. You know push button operation?
Yes, ma'am.
Okay, now do you know the symbol of it? Wait, give me a minute. Give me a minute.
Okay.
This is NO push button NO connection. Okay. Now before it is making on. Okay, when you make it on, this is how it look. So this is push button NC. So what you said, it is correct. It is NC only. Okay. Can
Okay.
anyone? Okay. So now with this, before owning the switch, this is an off state. This is an on state. Okay. This
Okay.
is when you consider a push button in NO form, NO switch, push button NO switch. Okay.
Okay.
Finished?
Yes, ma'am, I shared. Can you check once?
Okay.
I am also shared, madam.
Mallikarjun, yours is correct. Srinivas, I can't see the first two. Okay, Srinivas, yours is correct. May I know for which one you have written this? The first one and the second one? Srinivas, please mark it which is the first one, okay? First, 2NO. First one is 2NO, it's wrong. It's not wrong. But the second one is correct for the first one. And the first one is correct for the second one. Okay. Sushant, you got it? Did you try? Sushant, Gopi. Okay. So this one is clear, right? I just write once. Can anyone tell what is this KO parallel it's doing here? Can anyone tell what is this parallel connection called when you repeat the output address at the input side parallelly?
Means
Latching, madam.
Yeah, correct. So then no worries in explaining the latching. Okay, what about this one now? So now first switch is NO push button. The second one is NC push button. Now how does the ladder look? Radhakrishna, please tell.
ma'am,
Huh?
actually, whenever we push button will on, then uh, switch off the any function or motor or anything, then
I don't
NC
want
will
to push. I know you know the push button working. Now tell me how to write. If I'm using a NC push button, how it will work? Tell me that. Don't tell NO push button working.
like NC means flowing current direct, ma'am. Whenever a push button NC will operate, then NO.
Huh?
NC NO.
Don't tell NC NO. Tell it in a normal English. So you're explaining someone to a non-technical person.
Meaning is same, ma'am. Nothing.
Okay, now tell me how does NO switch works?
NO switch works means then we will
Push button NO. How it works? On means if I switch it on, output will be
on.
okay. Off means output will be
Off.
okay. Now, if I take push button NC, what happens?
NC
When I make it on, what happens to output?
off.
Off.
Correct?
Yes,
So
ma'am.
when you make switch on, output will be off. So this is not in the ladder condition. This works, the switching operation itself is like this. Okay. Now, how are you going to write the ladder for that?
Oh,
So now I have to represent this operation in ladder symbol. So which one should I be using?
NC.
NC itself. Now, if I use NC, what is the difference between this program and for this program? So now here, this is a NO type push button. I'll be using this. Okay, NO connection only I'll be taking. Now, how I'll be using it for this NC switch? Others, please answer. Should I take a NC connection only or NO connection? And why? Please, anyone answer no?
Madam, once again, question repeat it, ma'am.
Repeat it. It's simple. You need to operate this. Let's imagine this is a motor. You
Yes.
have one start button and one stop button. Okay. Now for start button, you're using NO type push button. And for stop button, you're using NC type push button. Okay. Now, how should I write a ladder diagram for this schematic? Okay. Now, same as above.
Same as above, madam. One NO, one NC, and then output, one latching. NO latching, output latching.
Srinivas, it's correct. Output latching. Latching you leave. Latching we'll see afterwards. Okay. Why latching comes, we'll see afterwards. Now tell me
Without
how this
latching, without latching push button, how will press, ma'am?
push button you latching you leave. First you understand this working of a NC switch. Okay, in industry they'll give you a wiring, do this NC switch and do a ladder diagram program. What will you do? So now here what happens is that whenever you are given with the NC push button, you will use a NO contact itself. Okay,
Okay.
got it?
Yes, ma'am.
It's a reverse operation. See, whenever I have a NC, like say whenever this braking condition is there, I'll take a NC operation. Why? Because whenever I give 1, output should be 0. Okay. Now, whenever I use this NC type push button, it will be starting all it will be giving a high condition, right?
Yes, ma'am.
So when I mean starting itself, it is a high condition. When I make it on, it will become off.
Oh,
Correct. So what I have to use? I have to use it in NO only, no?
okay.
If I use it in NC connection, so when I make it off, it will make a connection. It will allow the current. It will not stop the process. It will continue the process. Okay, got it?
Got it.
It's like minus into minus will be plus, no.
Yes, ma'am.
Okay. Now for this one. This one, everyone has like missed the things. I don't know why. So you have to see how are the outputs are operating for the different inputs. Okay. Now this E switch, when you make it A on, E will be on. When you make only B on, E will be
Yeah.
on. Correct. When I
Yes.
make A and B both on, E will be on. Correct.
Yes, ma'am.
Okay. Next, when I make D on, okay. When I make D on, that time if C becomes on, that time, so E also on. Okay. So now this E switch is depending on all the inputs. Correct? Similarly, the F output is also depending on the C. If I make D on, then only it will be depending on A and B. Okay. So
Okay,
how
ma'am.
many rungs you will be creating for this one? You have two outputs. How many rungs you will be creating for this simple bridge?
3.
One,
No,
madam.
no.
3.
One, madam.
1.
Yes, madam.
1 you will be using.
Yes, madam.
One you will be using. You have two outputs. So when you have single input conditions and if you have two multiple condition, the program will throw a error. And okay, if you don't connect, only in the parallel connection it will be working. How many rungs will be there in the program?
3, ma'am.
2 rungs will
One,
be there. There are 2 outputs. First, you have to see how many outputs are there.
2.
Okay, you will be having 2 rungs. Okay. Now, anyone please try to create only for E output and share your screen. I'll be making you host. Okay. So try it out and please, once you finish, let me know. I'll make you host. Please share your screen. Do it in this thing only, software only. Everyone getting it? Any confusions? Others?
In one rung we can't do, ma'am.
Hmm?
In one rung we can't do, ma'am.
In one run you cannot do it. Check it out whether all the conditions are satisfying or not. I don't think so. You cannot do it in one run. If
Already I have done, ma'am.
you have done,
Yeah, ma'am.
okay. I'll make you host. Share your screen, okay?
No, I am in office, ma'am. I
Okay,
have photo.
so
I will share through WhatsApp.
okay,
Please check.
fine. Okay, I will create that program only and I'll check it out. I'll tell you one more thing. See, you need not to create exactly how it looks like a circuit diagram, okay? Mallikarjun, how have you created it? Okay.
Ma'am, I
This,
shared.
yeah. Okay, I am seeing that one only. Okay.
Yeah.
Now, first. So, what is the first condition? Okay, I'll simulate this one. Okay, when I make A on, E should be on. Yes, it is working. Okay, when I make B alone on, so E is getting on, correct? Now I'll make A and B both on, okay? So that time also E is getting on. So the first 3 conditions are satisfied. Any doubts in this? Guys, any doubt in this?
No, ma'am.
Now, okay. So this one is D, okay? 0.03 is D. When I make D on, according to the schematic diagram, F should be on. F is getting on. Gopi,
No,
can
ma'am.
anyone know, right? Because the current
Yes,
isn't flowing from C itself. So now I have make D on. Okay, if I make D on, because of A and B are on, F also should be on. Okay. But here, even if I make D on, F is not getting on. That means this is not correct. Okay.
Okay.
So this is not correct. Now let me check.
Ma'am, that is in series, right?
Which one?
C and D.
C and D are in C and D are not in series.
Can you open one more time that Excel, that sheet?
See,
Sheets.
when it is going to E, that time only it is series. Okay. Now, this is for E. Okay.
Okay.
No. Yeah, this is for E. Now see here. A, B. Whenever. Wait a minute. I don't know. This split screen can be viewed. Are you people able to see both the screen? No, right?
Only one screen is visible.
Okay. Okay. Now from the schematic, or schematic open with continue. So whenever I make A on, whenever I make A on, E is getting on. Okay. So whenever I make only B on, E is getting on that time also. Okay. Now A and B acts independently on E. Okay.
Okay.
So it doesn't depend on D. But see, whenever see, when you on only C switch, it will not affect E. Okay.
That's fine.
Okay. It will not affect on E because D is in off state. Okay. When I make D on, then it will act on E switch. Okay. Understood?
Yeah. Okay.
So if you're getting confused, try to write the current flow. Okay. Now, can you try the second condition? Radhakrishna, you tell me, I'll write it. Okay.
Okay.
Sushant, are you getting it?
Yeah.
Okay. So, Radhakrishna, please tell me the conditions for F, how I have to connect.
Then C ma'am, NO. Put
C
the
and
C.
O. Okay.
Then directly high to the F output.
Okay. One second. Next. Now, I haven't on D. If I on A and B, will it work? Will it affect the
B.
F? When I make A on, D is in off state. Now, if I make A on, will it affect
B.
the F? Will it affect the F output?